Hello dear students, welcome to the channel. Today we are going to do something different. We are not covering lectures today. Today I'm going to cover the lab session of power system 2 subject. In lab session we are going to cover first 6 to 7 experiments, as you can see here. Let me show you the list of practicals. Here you are. So see, firstly we are going to check out the first experiment. I'm going to make you familiar with MATLAB environment. We are not going to discuss about the Simscape and Simulink environment, but basic MATLAB programming. I'm going to explain you that. After that, I'm going to tell you about the short transmission line analysis, which we already saw in the lectures. So basically, the first three chapters which we have covered, the first three playlists of Power System 2, which have been covered by me on the same channel. So the experiments of those three playlists, we will be covering those experiments here. So first we will be discussing the short transmission line analysis. We will use MATLAB environment for all of the experimentation work. Second, we will see the medium transmission line analysis. We are about to find the efficiency voltage regulation for both short and medium transmission lines. After that, we are going to do the same for long transmission line analysis, and again we will be finding efficiency, receiving and power, um, except for that most probably receiving and power factor. So that we are going to calculate about all three types of transmission lines. After that, we are going to calculate the ABCD parameters or generalized constants. We have already derived the ABCD parameters for all the type of transmission lines for short, medium and long. Remember, for medium we had two analogies, two different ways to represent the medium transmission line, which we called pi method of representation for medium transmission line and T method of representation for the medium transmission line. After that, we saw the long transmission lines. In long transmission lines, we used the rigorous method to derive the generalized constants. We also call them ABCD parameters, and we derived them based on two equations. So I'm not going to cover the theory part here. I'm only going to explain the practical parts, and I'm only going to explain the coding here. So if you want to know about them, if you are not familiar with all those theory concepts, I will be providing you the list of all three playlists in the description below, so you can click on the link and go and follow the whole um, lecture series. Except for that, if you want to check out the playlist, individual playlist, I will be providing the link of that in the I button as well, so you can check out whenever you want. The link will be flashing on the top right hand side corner of your screen, so you can just click on it and you can see the whole thing. After the ABCD parameters, uh, something that called per unit computations, which we did for all type of power system quantities entities. We did it for voltage, current, reactances, impedances, right? Remember in the very first playlist. So the practical part of that we will be covering today here. We are going to calculate uh, different aspects, uh, different things related to that computations. And after that, 7, 8, 9, 10 are the parts which have not been covered till yet. Seventh is on the go. It is running on the channel right now. The playlist is on the roll. So as soon as we complete all those playlists, the theory part, we will be jumping on the practical part, and we will see how to implement all those things. So firstly, we will be starting with the introduction to MATLAB. So let's begin without any further ado. So let me show you how the MATLAB environment looks like first, so that you can become familiar. And once you get familiar, we will be implementing few of these the 10 of the commands which are given here. I will be performing few of them for you. and rest you can perform on your own in the MATLAB. I will leave that to you. So let's see how the MATLAB looks like. uh, for our comfort, I have already opened the MATLAB. So this is the MATLAB environment. This is how MATLAB looks like. This is actually an old version. This is our 2016 A version. Every year MATLAB drops two versions of its software. We have our 2016 A and then our 2016 B. Same goes for our 2017 A and our 2017 B, and same for 18, 19, 20, 21, and now even 2022, right? So I'm not using the most latest software here, but still uh, it is more than sufficient for what the experiment work we are um, aiming to do here. So firstly, let me make you familiar with that. This top screen which you are seeing here is called the title bar, on which they have titled MATLAB R2016A. They are having the same buttons as any other software will have: minimize, restore, or maximize, and close. Here you can see the different sections in which you can roam around as per your wish. We are having home section, plot section, apps section, shortcuts, editor, publish, and view. So that's your menu bar. In that we have in home, just like the menu bar of any other software, we are having so many facilities here. You can open new file using it. You can create new file using this. You can start a new script. By the way, this square box which you are witnessing in the center, that is called the script. And whatever script you write using MATLAB, in the MATLAB language itself, MATLAB has language of itself. So whenever you write a script using MATLAB, the extension of that script will be .m. As you can see, I have used few examples, as you can see here. Just a fun exercise, I previously draw rows which you can plot using MATLAB. So let me show it to you just to get a better understanding. So this is your editor, or you can call a script. The section is called editor, and whatever you make in it, the file itself is called a script file, and its extension is .m. Let me show you. Wait a minute, I have to add to path. See, it's a rows. So same ways we are going to perform experiments. So this is editor window. On the right hand side, this place is called workspace. All the variables which you create, all the variables which are used, which are in the variables which are in use currently, will be shown here. As you can see, I'm right now using variables j, k, l, small n, small p, capital R, t, u, x, lot of. Now I want to clear it. All those variables, where did they came from? Actually, they came from the file which I just ran, the rows file, right? So let me clear it. For clear it, we use this command, clear all. See, now you can see the workspace is clear. So I have cleared the workspace, so there are no other variables loaded on the workspace here. So I think you pretty much got the idea what is the workspace. This window in which I wrote clear all, this window is called command window. If you want to execute something instantly, if you want to do quick implementation, or if you want to just check the code one liners, you can do all those things here. So you can do any mathematical things as well as any non-mathematical things as well in this window. So just like I wrote close all to close the workspace, if I want to clear the command window, there is a command for that which is called clc, and here you go, the command window is clear, right? Same as in command window, we can do any mathematical operations, arithmetic operations, or even vector operations as well. Like I want to add 5 plus 6 and I will get result. I want to add 45 plus 98, I will get a result. I want to uh, do multiplication, 2 into 3, I will get result. If I want to do the subtraction, 1 minus 5, I will get the result. If I want to do the division, 9 divided by 3, I will get the result, right? So you can do any mathematical operations, and it is not limited to your arithmetic operation. You can do any other things as well. Like, see, if I want to find the square root of let's say I want to find the square root of 64. See, you just have to remember the command, and don't worry, as you practice you will remember the commands. The command for square root is sqrt, so I wrote sqrt to find the square root of 64. Same way you can find the square root of any other number. Like I want to find for 256, here you go, 16, right? If I want to find any other number, like the square root of which number will not be actually the whole number, so let's try 45, right? Because we know the 45 is not square root of the whole number, so even that we will get. So you can do all those things here. And the special thing about it is, whatever you do in the command window, you see here you will be creating only one single variable. There is no other variable which is created, because I haven't created. If you want to create, you can create, right? If you want to store a is equals to 52, see, now a has been created. And if you want to do b is equals to 12, now b will be created. Now if I want to write c is equals to a minus b, then c will be created, right? But uh, whatever operation I do without assigning any variable in the command window, the command window store it in the already defined variable, which is called ans, or answer variable. See, the square root, for in order to do the square root, I didn't assign any variable, so it assigned ans variable itself, which was indicating value 6.7082, which was the square root of 45, just we what just we did over there, right? So I think pretty much you got the idea how the command window works. Let me clear it for you. First we will clear the workspace. Can anybody tell me what is the command to clear the workspace? We just did it few minutes ago. See, clear all was the command. And not to clear the command window, we can write clc. See, command window is clear. Now coming to this small this small strip which you are seeing here, it is actually the address bar. It is actually showing me in which directory right now I am working in. So right now I'm and the by default directory is C drive program files MATLAB R2016 bin. If you want to change it, you can change it. It's up to you. So you can change it, your choice. And based on that, based on this directory which you are working in, you will be seeing the current folder. So all these things, M3 registry, this registry, UTIL folder, Win64 folder, all these things are nothing but the part of this bin folder. So all these things are present in the bin folder, right? So now let me quickly show you how to change the directory. So I will go here, not this is back option, this is the open, right? So I will go here, I will open my PS2 folder, I will open my lab session folder, and I will select that folder. So that folder now became my present working directory, right? And this is the current folder section. In that section, what you will see, all the files present in that folder will be seen by will be visible in this section. So you can see I have already did good work and already created the files which we are going to perform experiment on. So we don't have to write simultaneously as they explain you the code. So I will be simply explaining you the code, then we will be running the code and we will be seeing the outputs, except for the first experiment, because in that I'm going to use the command window so that you can get a little bit more familiar with MATLAB itself, right? That was the current folder for you. Except for that, there is a detail bar. If you want to see the details of any file, let me say I have selected this file, PS2 example 3. So I will be able to see the details of this file over here. As you can see, the practical 3 example 3, analysis of medium transmission line. So this analysis of medium transmission line, practical 3 example 3, is the code. What is the script written inside it is the code, right? Same thing you can see for any other. It's the script. You will see when I will open them. Let me try to open this PS2 experiment 2. Here you go. So see, the analysis of short transmission line, practical 2 example 2, is the first line of it. So you can see the first line in the script over here. So that was your current folder directory. We have already seen the current folder, editor, workspace, command window, and details section. So now what we will see, let me quickly give you a glimpse of what menu bar can do. You have already seen the menu bar, what it can do. You can find the files using it. If you want to compare to scripts, you can use it. If you want to print something, you can use this print section. There is just an arrow for going back and forth, just like the back and forward uh, button in your my computer or this PC. If you want to go to a particular section or particular function, so you can go using this. There is the find button. If you want to find something, you can find using this. Insert, so you can insert few things, like if you want to insert a graph or a function, so you can do that. Comment section is basically the section which we use if you want to remember something, but you don't have any utility of that thing in your code, so you comment that thing out. We call it commenting. So just like that, I have commented it. Like, see, the first line has been commented in this code. Analysis of short transmission line, practical 2 example 2. I have commented this line. What does it means? That this line is not contributing anything to my code, right? My code doesn't has anything to do with this line, but this line is giving me something, some information. It is explaining me something. What is it explaining to me? It is telling me that this is the practical 2, this is the example 2, and what is it about? It is about the analysis of my short transmission line. Same thing you can see here as well, practical 2 example 1. What is it telling me? It is telling me the analysis of short transmission line, right? Same thing you can see here about the medium transmission line. So that's what it is telling me. If you want to do indentation, indentation is actually used whenever you are using any conditional statement or a loop. Whenever you want to get into some statement or a function, we use the indentation. So basically what do? We write the statement, like I'm writing that I'm writing, if this will happen, then what will happen. So an if statement, I have to do the indentation. I have to uh, uh, separate, I have to leave 4 spaces before starting my script, and that indents that whatever script I have written after indentation is the part of the uh, whatever statement written above it. So that is indentation for you. There is a breakpoint section as well. You want to clear everything, or you want to clear some particular section. If you want to enable or disable the line, which is a line or breakpoint, whichever you are working on presently, so you can do all those applications based on current line or some particular line. This is the run button. The run button is actually used to run the file which is present in the editor. As you can see, ps1 example 1 is the file which is present in the editor, and I can run it using run button. Then we have run and advance. So if you are using any model file, if you want to move further after running it, you can use it. If you want to run up some particular section, you can run it using this run section. If you want to move advanced only, you don't want to run it but you want to move advanced without running it, so you can do it. And this is the run and time, which means it will provide you some time that run this code for some certain period of time, like run this file for like 5 to 10 seconds, right? So that's your editor section. You have home section, and I think you will uh, as you will play with it, as you will toggle with it, you will start to learn about it. So just keep toggling with it, keep playing with it, and you'll learn how those things work and how things function here, right? So so the more you toggle with it, so the more you work with it, you will get to know it much better. And that's what I wanted to explain to you about the basics and different sections of MATLAB. Now let's begin with our very first um, experiment. So let's come back to the manual. What does the first experiment say? We have to run certain MATLAB programs, MATLAB commands, and see what is the first MATLAB command. We have to solve this problem. We have to find the value of x is equals to e raised to minus 2.5 into 10 raised to minus 4 plus 1.5 into 10 raised to minus 6. You want to find the value of it. So how will you do it? What will you do? So here's what you will do. See what I have done. Exp stands for the exponential. If you want to run the exp file as we have done here, you can do it. Then what else can we do? In order to present the multiplication, you write the star sign. Always remember, if you are having any value which is holding negative value, like this 2.5 minus 2.5, then present it and the other one which is getting multiplied with it in the bracket, separate brackets, right? If you want to write raised to, like 10 raised to power 4, so raised to is raised to can be used using this symbol and the same ways. And let's try to run it, see what comes up. See, we got the value of x is equals to 0.9998. That's the value of your x. Now let's come to the second one. What is the value of second one? See, y is equals to log 20 minus log 100 base 10 plus root 3 of log 5. Now we have to execute this. Now how would you do it? So let's see. First let's clear the screen. CLC, here you go, and then we will write the command. I have already copied the command so that we can save as much time as we can, because the session is going to be a long enough. So I'm not going to write every command over here, so just to make it easier. So this is the command. Log is represented by log itself basically, so you can see it. We have used the square root command earlier as well, so you know how we can represent the square root, sqrt. And y log 20 minus y 100, y is equals to log 20 minus log 100 base 10. So if you want to write the base, you can write without space immediately after log. There was no base specified, so if you want to specify it, it will take the default base, which is, I think, default base is I'm not sure what is it. Maybe it is 2. I'm not sure what the default base is, sorry. We can google it whenever you want, right? Then plus square root of 3 into log 5, and let's see what output will we get. Here we are. Okay, one thing I forgot to explain, that in order to run this, you just have to press enter. You don't have to do anything, just press enter and it will get executed. So here we got the value of y is equals to 3.7834, and you can verify it with your scientific calculator if you're having one. I'm not going to verify it because time is a very important constraint here. Now let's come to the third one. What's the formula? What do we need to find here? See, we have to find y is equals to e raised to x plus log x root 2 base 3. No, third cube. Okay, the cube root you want to find here. So what you will do, uh, because we already know all the rest of the things, like in order to write e raised to x, you will just use exp function, exponential function. For log, we also know we use log for log, and for the cube root is the only thing which we don't know. So in order to use the cube root, there is a function called nth root, so you can find whatever root you want to find, like if you want to find the square root, fourth root, fifth root, you can find it based on that. So you can simply just mention it. I'm not going to run the whole thing because time is a constraint. I'm going to run the fourth one. So let's see how do we do the fourth one. So I will ask you to write the command of the third one in the comment section below. If you can crack it out, let's see who can crack it out first. Fourth one is basically creating a matrix. We want to create a matrix called A, which is which is a 3 by 3 matrix, and it holds the value 25, 3, 20, 1, 6, 9, 65, 7, 84. Right, and then we have to do all this operation. We have to extract the second row of the matrix. Then we have to do the multiplication of A with 5 and all those. Let's first create a matrix, then we will see what we can do with it. Before going to that, let's clear the screen again, so that we can store A in new variable. We can take A as a new variable. Right, there is a two variables here in the workspace already, right? Because we just wrote CLC, we cleared the command window, we didn't clear the workspace. In order to create a workspace, what is the command? Clear all, right? Don't forget it. So let's try to create a matrix called A. So I already created it, and here it is giving me output. So how do we create the matrix? Simple. You just need to mention the values of the elements in the row of your matrix in the bracket using space. So I took a bracket 25 space 3, as you can see here. I'm getting 25 space 3 space 20. Whenever you want to add a new row, what you will do, you will use the semicolon, and then you will add the remaining members of that particular row. So 1 space 6 space 9, I got 169. Then again semicolon, which will give me a new row, 65 7 84, which give me the third row. And I'm making a request here for you, that don't just see the lecture. I want you to perform the experimentation simultaneously with me, so you can get better idea, right? If you would make any error, it will show you that, oh okay, there's an error coming over here, and from that only you will be able to learn the coding, because coding or programming is not something which you learn by watching. You have to perform it, right? So here we created the matrix called A. Now what was the other thing which it needed us to do? It want us to extract the second row of the matrix A. So what we will do, we want to extract the second row of the matrix A. So what we will do, let me show you. This is the command to extract the second row of matrix A. B is the new variable which I took, and B is equals to A 2 comma colon, right? So this 2 indicates the second row, and this colon, which means uh, which column you want to extract. Okay, which column you want to extract. If I will mention the column here, it will extract all the columns. If I mention any value here, it will extract some particular value. Let me show you. I will take z here, and I will make z is equals to a 2 comma, and which column we want to 2 is the my second column, so 169. Now I want to extract this 6, so what I will write, 2 comma 2, and I will simply run it. See here, 6. If I want to extract a particular column, what I will do, I will write z is equals to, by the way, if I'm taking z again, which means the value of the previous value of z will get replaced, right? So now I want to extract the whole column itself. Okay, I don't want to extract the row, I want to extract the column, this column 3 6 7. So what I will do, second column 2, and here I have mentioned the colon symbol. So the colon symbol stands for the whole thing. So see here, I got the whole column, right? So by now I think you got the idea. Now what does it wants us to do? The third thing, it wants us to multiply the matrix A with what? It would want us to multiply A with 5, right? So what we will do, wait a minute, okay, so here we will take a new variable called g, and we will write g is equals to, we will take a into 5, multiplication with 5. So g will be multiplied with 5, which means all the elements will be multiplied with 5. So g will be what is the 25 into 6, sorry 5, 25 into 5 125, 3 into 5 15, 20 into 5 100. So we'll get values like that. Let's see. Yes, we are getting values like that. What's the fourth operation which it wants us to perform? The fourth operation is add 3 to each and every element of the matrix. If you want to add some number to each and every element of your matrix, you can do it simply by doing something like this. H is equals to a plus 5. So you will add 5 to each and every element. What are the elements? 25, 3, 20, right? What is the 25 plus 5? 30. 3 plus 5, 8. 20 plus 5, 25. Let's see if we get some values. Yeah, we're getting same values. 3, 3, 0, 8, 2, 5, right? We are getting the value. Now it wants us to find the size of a given matrix. We all know what is the size of matrix A. It is 3 by 3. So what we will do here, we will simply write size of A, and it is giving us, yeah, see, 3 by 3, right? So you can do here. Now that the whole sum is finished, what we can do, we can clear all. So we can clear the whole workspace, and we can clear the command window as well. So let's put clear all and close all. See, here you go. Now there is something interesting. Plots, it wants us, the fifth exercise sheet, it is telling us to program to create a sine wave. And being an engineering student, you might know what sine wave is, right? I'm assuming you already know. I'm not going to explain what sine wave is. Okay, so it wanted us to plot the sine wave, and uh, how did we do it? So let me show you how did we do it. So this is the code to plot a sine wave. We took the interval, we took the time from 0 to 10, and we took a sample at every 0.02 instant, and sine t is the basically code for plotting sine component. So here's your sine wave. It's starting from 0 going to 1 coming to -1, just like it should, right? And we are taking instead of we are taking values at point 0.02 and we are going till 10, right? So by mean going till 10, so which means consider it every one sample at zero 0.2 seconds, right? And if you will go till 10 seconds, the total number of samples which you will have will be 500, and you can see that 500 here, right? And it started from t is equals to 0 because we wrote t is equals to 0. You can see I tried to implement the labels here. X and Y label may not be visible, no issue. So that is your sine wave. Now let me clear the whole thing again. Wait a minute, I will clear the whole thing again. Before that, let's see what else we have to do. Okay, now next it wants us to write a program to create a circle with center 2 and radius 5 centimeters. So let's do it. Let's come here, and here you go. So the formula for plotting a circle is S circle 1, and you can mention the diameter or radius or whatever you want to mention. You can mention. See, it wants us to take center as 2 2 and radius is 5, so we took 2 2 as the coordinates, and this is the radius 5 which mentioned here, and just simple plot function, plot AB, and it will plot the AB for us. So here you go, it will come, it will take a few seconds. Okay, here it is, here it is. So this is the figure, this is the circle. See, the radius is 5, and it radius is 5. How can you how can you be so sure? See, starting from 2 it's going till -3, starting from 2 going till 7. So radius is 5, starting from 2 2, right? And you can see it might look like an oval a little because of the scale, because you can see here it is only going till -3, but because scale is longer here, but it is a circle. See, it is going from 2 to 7 here as well, and from 2 to -3 here as well, right? So that is a circle. Now again, let's clear everything, and let's see what else is there. So let's see what else we have. So the next one is the evaluate the given function and plot its response for the values of a ranging from 0 to 10 with a step size of 0.1. Okay, so step size has been mentioned. We have to take the step size of step size of 0.1, and the range should be 0 to 10, and the function looks like this: s is equals to sine 2 pi 5t plus cos 2 pi 3t plus e raised to minus 0.1 raised to t. Now let's try to do it here. Let's try to plot it here. So it mentioned, it has been told, we have been told that we have to take 0 to 10, step size is 0.1. So see, t is equals to 0 to 10, step size is 0.1, right? The middle one is the step size, and 0 to 10 is my limit. And same ways, for pi you can write simply pi, it is pi. So st is equals to st, or was it just s of t? Yeah, so st we can write st is equals to sine 2 into pi into 5 into t cos 2 into pi into 3 into t plus We know how to plot an exponential function, so we also did it. And simple plot function to plot my whole function against st, uh, t against st, right? So let's see what will happen when we run it. And here we go. This is the function. See, you can see the sine and cosine functions here, and you can also see the exponential effect of exponential here, right? See, it is decaying is little slowly. So that was that function. Now again, let's clear everything up. And let's see what else is there. Now it wants us to calculate the inverse of this matrix. The matrix is 1 1 1 1 0 1 minus 1 0 0. So we already know how to plot a matrix, so let's plot this matrix. And this is the formula, and here is my a. Now it wants us to find the inverse, and if you have taken any of the calculus classes, if you have paid good enough attention in the calculus classes, you might remember what is the formula of inverse. So can anybody tell me what is the formula for inverse? But actually the catch is we don't even need the formula of inverse here. We can find the inverse without formula. How? Simple. Let's take the variable b, and just take a small b is equals to, simple, just write I and v of a, and you will find the inverse of whatever matrix you want to find. So this matrix is actually an inverse of matrix A. If you don't believe me, you can check it out by yourself, do the math, do the formula, find the adjacent matrix and um, determinant of your matrix and whatever you want to do, and check it out. It will give you the inverse of a matrix. Next one, and most probably the last one, because it has been dragged out too long, the ninth one, which tells us to find the two complex numbers and convert them into polar form, which shall be so interesting. Uh, Now we have to write any two complex numbers, and we have to convert them into polar form. And how will you do it? Let's see. So let's try to do it. Let's consider two complex number and convert them in polar form. So I have already got the code. So the code is, first I took the complex number a, which is equals to 3 plus 5j. So I wrote j into 5. That were good thing with MATLAB is it understands the complex and polar forms. So it will understand it is a complex number. B will be equal to 4 plus 5j. So it will consider that okay, it is a complex number. Now I want to find the value of a, so I just have to mention value a is equals to, value a is, by the way, just my another variable. You can name whatever you want to name it. Is equals to abs of a, which means absolute of a, and it will give you the value, absolute value of a is equals to 5.8310. Then you want to find the angle of a. How can you find the angle of a? So you have to take the tangent of your uh, complex complex value divided by your real value, right? Imaginary value divided by your real value. And how do you do this? So for 10 of 5 divided by 3, and by doing that you will find the value of uh, angle a, which is 1.0304. Same thing you can do with b as well, and you can find the value of b as well. So that was that for the first experiment. Now we will start the second experiment, but before we jump towards the second experiment, let's clear out the workspace and command window one more time. So here you go. I cleared the workspace and command window for you. Now let's jump to the experiment, and for this experiments we will need your editor, because we will be playing with a number of variables, and when you have number of variables, remember always use editor, not command window, right? But either ways you have to clear the workspace, so we did. Now about the codes which I have used here. Whatever codes I am using in experiment, I am providing those codes in the lab manual as well. So you can do it whenever you want to perform an experiment, whenever you feel like performing an experiment by yourself, and you can learn, improve as well. So I will be providing the codes in the lab manual as well. And the second thing about the manuals, uh, I will be providing the link of the manual in the description below if possible. If you cannot find it in the description below, you can reach out to me and ask me to provide a lab manual in the comment. Personally, I will provide you the lab manual. Okay, so no worries about it. And without worries, let's start our first experiment, technically second experiment. Let's see what does it says. So already I have whatever the code I'm using, I have already put it in the manual here, so you can do it by yourself as well. And here you go, the first question. What does it says? It says an overhead single phase line which is delivering 1100 kilowatt at 33 kV with 0 0.8 power factor lagging. The total resistance of the line is 10 ohms and the total inductive reactance is 15 ohms. And we need to find percentage regulation, sending end power factor, and efficiency of my transmission line. Right now, to understand the code, because I am not going to explain to you how transmission line works in this video because we have already did it in the previous videos. So if you want to learn it, check out the playlist. You can learn about the short, medium, and long transmission line in the playlist. But I will be assuming that you are already aware of how the uh, three types of transmission lines work and what are the formulas it follows. So based on that, I will be explaining you the code here. So we have an overhead single phase line which is having power of 1100 kilowatts, running at 33 kV and having a power factor of 0.8. And we have been told to find the value of percentage regulation, sending in power factor, and efficiency of your transmission line. Now very obvious thing, you if you want to find the value of these quantities, you must know what is the formula for these quantities, right? So uh, that also I have mentioned here. I will be showing in the manual itself as well as in the code. I have mentioned the formulas in the code as well. Here is the formula of percentage regulation. VR is equals to Vs VR minus VR divided by VR. Same ways, here is the efficiency, right? Receiving end divided by sending in power. And same ways you can find the value of your sending in power factor, right? Cos phi is equals to VR into cos phi r plus IR divided by Vs. So let me show you the code line by line. First, what we have did, we took the first variable called PR. It is nothing but my receiving end power, which I have mentioned in the comment as well. My VR is my receiving end voltage, and uh, we want these two values of VR and PR from the person who is running the code, right? So we want the values of them in the output, not actually in the output, but we want the values of that to be entered from the person or user who is actually running the code. So if you want to do that, if you want any input from the person who is running the code, you will write input and then you will mention whatever thing you are asking for in the in your inverted comma and quotation mark basically, and then what you will do, you will enter uh, the value whenever you run the code, not whenever you're writing the code. Same way as I have did for R and X. R and X are my resistance and reactance values. Then we have the power factor, receiving and power factor. So cos power factor PIR, receiving end. Okay. So these are the inputs which I want the user to enter it, and then I will be putting the formulas, right? Because the values will be in kV, kVA. So I need to convert it in the voltage or watt. So for that I have multiplied it with 1000. Then you know what, you want to find the VR is Vs minus VR divided by IR. So for that you would need to find value of you need to find the value of Vs first, right? And uh, VR is already given to you. You already know what is the value of VR because it has been given to you in the question itself. So what you will do, first you will find the value of Vs. And how you can find the value of Vs? For value of Vs you will need value of current. So you can find the value of current based on your receiving end power and receiving end voltage. Both of them are given. Power factor is 0.8. So you can find it. I is equals to PR divided by VR into cos PIR, which is power factor. Based on that you can find the sine value, right? Sine value of my power factor, sine PHIR will be square root of 1 minus cos PHIR square, right? Because basically we are applying a formula of sine is equals to square root of 1 minus cos square. So by doing that we will be able to find the sine value of it as well. And when we have both the values, sine and cos values, we can use the formula of Vs. Vs is equals to VR plus I into R cos phi R plus X sin phi R. Okay. If you don't remember the formula, please watch the previous lecture videos. This is the formula to find the sending and voltages for my short transmission line. Basically we are dealing with short transmission line as well, only the short transmission line in the beginning. Later on we will be moving on the medium and long transmission lines. So this is the formula for Vs, sending in voltage of my short transmission line. When I applied it, I will be able to find the value of Vs, and once I got the value of Vs I can apply the formula of voltage regulation, which is Vs minus Vr into 100 divided by Vr. So simply I applied it here, and I will be finding the value of voltage regulation. After that I have been asked to find the value of sending in power factor. So it is basically very simple formula we had for it. Cos phi s is equals to Vr into cos phi r. Cos phi r is my receiving end power factor, Vr is my receiving end voltage, plus IR divided by Vs. So that was the formula. I'm telling you again, I'm not going to explain each and every formula in detail because we have already discussed it in the previous lecture. So if you want to learn about it, please visit those lectures. Okay. So by using this formula we can find the value of cos phi s, which is my sending and power factor. And now to find the efficiency, efficiency is PR by PS, or receiving end power divided by sending end power. Or you can also call receiving end power, you can say your sending end power, because you already know receiving end power, right? You need to find the sending end power. So what is the sending end power? Sending end power is nothing but your value of your receiving end power plus losses, right? Agree or not? Value of receiving end power plus losses will be uh, value of PS. And how can you find the value of losses? Losses is I square R losses, copper losses. We will be only considering, because we are considering about transmission line, we will be only considering copper losses. So I square R, you already know the value of I, you already know the value of R, so you can find the losses. Now you know the value of losses and PR both, So you can find the value of PS, and once you find the value of PS, efficiency is PR divided by PS into 100. So you find the efficiency as well. Now the good part, the important part, because one okay, your code is done, you have already finished the work here, but you want to represent it in very decent form, right? You don't want to write like, whenever I run the code without last three lines, what will happen? It will show me the values, but it will not tell me if whether it is an efficiency value or voltage regulation value. So you will get confused. So we use fprintf function, and by using this function, what we can do, we can show it that result of calculations for transmission line, that will be the title line sort of, and you can show that sending end current is, you can write it percentage f ampere. Percentage f will be the value of whatever value we got in the floating point variables, floating point numbers, and the first percentage f will indicate the value which I mentioned first here. See, let me show where, this I, right? I have to mention it which percentage f, which variable I'm talking about. So I'm talking about I here, so I have to mention I first. Then slash n is basically a tool to write anything in the new line. So in the new line, it will write sending in voltage will be modulus f. Sending in voltage, what is the variable used for it? It is Vs, so it will mention Vs. And the sending in power factor, cos PIS, cos phi s, which is the variable used for cos phi s, cos PIS is that. And same ways, fprintf, the efficiency of line and voltage regulation has been shown using these variables, efficiency and voltage regulation. So we will do this. Now let's try to run this code and let's see what we will get. Again, remember, there were some variables which we have been asked to enter, so it will ask these inputs first to us. Let's run it and let's see. So it is asking what is the value of PR. Let's come here and see what is the value of PR. PR is my receiving end power, so value of receiving end power has been given to us. It is 1100, 1100. So we will write 1100. Now we have been asked what is the value of VR. So it is 33 kV, as you can see here. Power factor, we also, let's see, power factor is 0.8. So 33 is VR. Okay, now it's asking for R because we mentioned R third. So how many ohms we are having? 10 ohms, and reactance is 15 ohms. So R is 10 ohms, reactance is 15, and cos pi R, so receiving end power factor was 0.8. So now once we enter all the values, it did all the calculations and it is giving us the output. See, it is showing us the sending end current value. So we calculated here, this I was my sending end current value. Then I'm getting the sending end voltage value, which we calculated here. Vs was my sending end voltage value. Sending end power factor, which we calculated this, cos PIS, which is also showing here. It is showing me efficiency, which is 0.98, efficiency of line. We calculated efficiency here. The efficiency is very good, 98.44. And then in the last, see, in the last we had voltage regulation. So voltage regulation is last, and voltage regulation is 2.14%. So that was it for the short transmission line. Now let's first clear it and we will move forward to next one. Now let's see the second experiment. Now what does it tell us? What question does it raises? Let's see. By the way, I have also mentioned the output in the your manuals as well, so you can check it out, check out the output as well, and you can match if your output is correct or not, if there is some error in your coding or anything else, so you can check it as well. See, our efficiency was 98%, so we got the right efficiency, and voltage regulation was 2.14. So we had the correct voltage regulation as well. Next time we will what we will do, we will verify it as well. Okay. Now let's come here. Let's see what we had and what we have been asked. So a single phase 11 kV line with length of 15 kilometer is to transmit 500 kVA. The inductive reactance of line is zero point 0.5 ohm per kilometer and the resistance is zero point 0.3 ohm per kilometer. See here, they have given values in ohms per kilometer for both inductive reactance and resistance. And we have been asked to find the efficiency and voltage regulation, and power factor is also given as 0.1 0.8. Now let's try to do the calculation. Let's do the math again for it. uh, Two things we have been asked: efficiency and voltage regulation. We know the formula for both of them, so let's straight up jump to the chase. There is one small catch here: O in ohm per kilometer. The line is 11 kV, so we will be multiplying it with 1000, and for kVA as well we will be multiplying it with 1000. Let's come to the code. Here we go. Here's the code. Same way as earlier. What I have done, I have wrote the input function and I have imported all the values for SR, VR, R, X, length and cos PIR. So it's same as the previous experiment, so I'm not repeating it. Hold up a minute guys, I'm getting a call from somebody. Okay, my sincere apologies for the call guys. Okay, sorry for inconvenience, but let's get back to the topic. um, Now what we had, multiplication I have already explained. Now capital R is equals to R into 1, and capital X is equals to not 1, it is L. L is actually length, right? Because it has been told, we have been told that we are getting the value of resistance in ohm per kilometer, so I'm multiplying the value of R and X with length so that we can get the total value of resistance. Small r is the resistance per ohm, so by multiplying it with length we can find the total resistance, and same goes for the reactance as well, right? Small r and small x, receiving end resistance, receiving end reactance. Now in order to find the voltage regulation we have to do the same thing again. We have to find the value of Vs, and we already know how to find Vs. We did the same thing in the previous one as well. We found I, we found sinusoidal component of phi r, receiving end power factor, receiving end angle, not power factor, receiving end angle, and we found value of Vs based on that. And based on the value of Vs again we found the voltage regulation, so I'm not repeating the same thing again, the explanation of Vs. Same ways we will be finding this sending in power factor. The formula is same, and same ways the way we found the value of efficiency, we will be finding value of efficiency, and then we will be using printf fprintf function to find to print my values, right? So let's try to run it and let's see what will happen. Here you go. Now it is asking us for the value of SR. What is the value of SR? So where did it go? SR is my sending and wait a minute, SR is not sending, it is receiving in power, sorry. So how much receiving in power I'm having? Receiving in power is 500 kVA, right? The single phase 11 kV line is transmitting, okay, 500 kVA, so I will write 500 here. What is the value of VR? Receiving end voltage, how much has been given? It has been given 11 kV. 11. Resistance and reactance. So resistance is zero point 0.3, reactance is 0.5. 0.3, zero point 0.5. Length, how long the line is, 15 kilometers. So, and also power factor is zero point 0.8. Length is 15, zero point 0.8 is my power factor, and here you go, it will give you the calculations. Here we have the values of sending and current, sending and voltage, sending and power factor, line efficiency, and voltage regulations. So pretty much similar to the first exercise or the first experiment, we performed the second experiment as well. Now one more time, let me clear the workspace and command window one more time. So it is clear. Oh, again, oh sorry, we forgot to verify the results. Okay, no issue. You can check it as per your wishes, or okay, you can check it. Okay, just check it by yourself. I'm not going to enter all those values one more time. You can check it by yourself. The third one, about the medium transmission line. This time what do we have to find? We have to find there is a three phase 50 hertz frequency is given, 50 hertz. We are having a three phase supply this time, 100 kilometer length of my line, and it has been following the line constant. Resistance per phase is given 0.153 ohms. Inductance per phase per kilometer has been given 1.21 millihenry. Capacitance per phase per kilometer has been given 0.00958 microfarad. So if whenever you have microfarad, you have to convert it into the Faraday. Same will be go with Henry as well. The line supply of load of 20 megawatt. So load is 20 megawatt of 0.9 power factor. This time power factor is 0.9, and it is lagging in the line voltage of 110 kV at receiving end. So it is lagging and voltage is 110 kV. And we have been told to use the nominal T representation to calculate the sending and voltage, current, power factor regulation, and efficiency. Okay, the S has been cut out, sorry, please don't bother. We have to find the sending and voltage, current, power factor regulation, and efficiency. So let's get started. What we will do, again same ways this time too, we will ask the user to enter the inputs which have been already provided to us. Receiving and power factor will be inputted, will be used as an input. Same ways the receiving and voltage, I wrote voltage here, sorry, voltage. The resistance will be again has been inputted. Inductance, capacitance as well, because this time we are dealing with them as well. We will be inputting transmission line length and the value of receiving and power factor. Frequency we are not inputting because for the most of the cases in India we use frequency of 50 hertz, so we are entering it by default. 50 is equals to f is equals to 50 hertz. Now we are multiplying VR with 10 raised to 3 because the value of VR will be in kV, and we will be converting it into the phase value. So we will be dividing my VR by root 3, so we can find the phase value of VR. Then with receiving and power, what I will do, receiving and power, I will be multiplying it with 10 raised to 6, because why? See, it is given in where did it go, in megawatt, right? So we have to multiply it with 10 raised to 6 here. And again one more time I am multiplying it with L, because the value of reactances and capacitance has been given in per phase per kilometer. Okay, sorry for the inconvenience, one more time, please forgive me. Again, continuing what we were discussing, that my capacitance and inductance are having the value in per phase per kilometer. So in order to find the absolute value, we have to multiply it with length as well, right? So for resistance, we are multiplying with only length. For reactance, we have to multiply it with 2 pi f, because value of inductance has been given. So okay, in the previous example, remember, in the previous example we had the value uh, which was given in ohms for the reactance part, but here we have been given value of inductor, right? Inductance value has been given, so we have to multiply it with 2 pi f. So we will do it. So come here and see, we multiplied it with 2 pi l, and then we multiplied it with the length. Then we try to find the value of z, r plus jx. So that will be your impedance. And then we try to find the value of your capacitance, admittance. Then j into 2 pi f c, and again I multiplied with l. Pretty much self-explanatory. Same way, same as inductor. What I did. Now we want to find the value of ABCD parameters on the pi model. So uh, quickly, based on quickly revision, that what were the formulas of ABCD parameters. So these were the formulas: a is equals to 1 plus y into z divided by 2, b is equals to z, c is equals to y into a plus yz divided by 4, and d and a are always equal, always similar, remember. So that were the values of ABCD parameters, so I mentioned it here so that we can find the values of ABCD parameters. But first, uh, we also have been told, let me come back to the question: sending in voltage, current, power factor, regulation, and efficiency. Okay, so to do that, first we will need to find the ABCD parameters, and then we will be finding sending in power factor, voltage regulation, efficiency, and what else, current. So same ways, we came here and we found the value of Vs and Is. So we have the value of A. Once we find the ABCD parameters, based on that, remember these two are the equations we used to use to find the value of ABCD parameters, right? So based on value of Vs and Is, we will be able to based on the value of ABCD parameters, we will be able to find the value of Vs and Is. So how will we find it? So Vs will be equal to A into VR phase plus B into IR complex. And how do we find IR complex? So first, how we find the value of IR till here, right? It is nothing but PR divided by uh, root 3 VR into cos phi. For in order to find IR complex, or what did we do? IR complex is IR star, if you remember the formula from back when the lectures we discussed about it. So IR star, what you will do, you will take IR, you will multiply it with uh, receiving and angle, receiving and power factor angle. So cos phi r minus j sine into power factor cos cosine of cos phi r, and by doing that you will find the value of IR star or complex IR. And when you have all the values, you can find the value of Vs and Is, because you already know ABCD parameters. You know the value of VR phase, and you know the value of IR star, so you can find the value of Vs and Is as well. Once you find the value of Vs and Is, uh, this value will be the phase value, so you can take absolute of it. and you can take the square root for Vs in order to find the line values. So Vs line will be Vs divided by Vs into root 3, which will give you the value of line voltage. Now you have to find this sending in power factor. So cos phi s will be given as uh, cos of the subtraction of the angle between uh, voltage and current. That's what power factor is, right, basically. So you will use the basics here and you will find the value of power factor. Same ways for voltage regulation, go back and check the formula. The formula, what does the formula says? Voltage regulation is given by this formula, right? VR in L minus VR divided by VR into 100. So don't get confused by VR and L. It is nothing but absolute of uh, line voltage divided by A, that is your VRLN, and it will give you the value of voltage regulation. Same ways for efficiency, you have to take PR divided by PS into 100. You don't know the value of PS, so you can find it. Sending in power will be root 3 Vs Is cos phi. So you will do exactly that, root 3 into Vs Is cos phi, right? Line voltage. And same ways you can do for the T model as well. This time the value of ABCD parameter will differ. Rest of the things will remain same. Absolutely no change at all. A small one two small changes because on the analogy of T model, but most of the things will remain same, and you will be able to find it for T as well. So I'm not explaining everything in T. I'm expecting you to go through it by yourself. If you have any doubts, please mention in the comment section below and we will address your doubts immediately, right? Now let's try to run this one. Let's see what will come up. Here you go. The value of PR has been asked. This time let's do one thing, not do the same thing what we did it last time. So let's verify it from the output itself. So value of PR is 20, VR is 110. So PR is 20, VR is 110. Value of R 0.153, 0.153. Value of inductor is 1.21 into 10 raised to minus 3. L is 1.21, 1.21 into 10 raised to minus 3. Value of capacitance is, where did it go? Okay, 0.00958 into 10 raised to minus 6. 0.00958, was it 958 or 985? 958 into 10 raised to minus 6. Now the length 100 and cos phi r is 9.9. And here you go, you all the values has been calculated for you and given here. So our workspace is full, as you can see, because we had so many values, right? So when we entered all those values, what did we got in return? Let's see here. We got the results for, firstly we have seen the results for nominal pi transformation, and sending in current is 109 amperes, sending in voltage is 115645 volt, and sending in power factor is 0.942427. Let's verify it. See, the values are matching. Good, right? Efficiency is 97%, voltage regulation is 5.73776. So the efficiency is 97% and voltage regulation is 5.7376. Cool. Same ways for nominal T representation, we are getting current is 109 amperes. Sending in voltage is 115646 volt and power factor 0.9426. Check it, 109.04, 11564 and 0.9426, correct. And efficiency of line is 97 and voltage regulation is 5.73. So 97.14 and 5.73. So here you go, that was your third practical. Let's move forward to last two practicals. Before that, again, always remember, clear the screen, close the command um, clear the workspace and clear the command window. So now that's out of the way, let's see the fourth experiment. And what does it has to say? What does it tells us? Let's see. Okay, it was fourth to begin with. So this time we are talking about the long transmission line. And remember, when we talk about the long transmission line, which method we talk about? We talk about the rigorous method. So let's see what has been asked from us this time. So let's consider our 230 mile, or in the bracket they've given the mile to kilometer. So we have 370-kilometer long 50 hertz transmission line. Series impedance is given, Z is equal to 0.1603 plus J 0.8277 ohm per mile. Okay, so they gave it in the mile. Okay, you don't have values in kilometers this time, might be a little bit tricky. Shunt admittance wise is given as J 5.105 plus 10 raised to minus 6 mho per kilometer. Okay, the load on the line is 12 megawatts at 125 kilovolt with unity power factor. So this time the power factor is unity, that is a catch. Good thing. We have been asked to find the voltage, current, sending in power, voltage regulation, four things. And we have been also asked to draw the wavelength. We are also asked to find the wavelength and velocity of propagation in miles and miles per second respectively. Okay, so a little bit tricky, but let's see. So firstly, what we will do, initially we will be calling all those inputs, just like we did in the previous few experiments. So we will be using receiving in power, receiving in voltage, impedance, admittance, transmission line length, and receiving in power factor. We will ask the user who is going to run the code to enter all those inputs using input function. Frequency, again we took frequency 50 and we mentioned it for the same reasons we did previously. Same is true for PR, VR, and VR phase, right? Same thing will be true for Z, capital Z and capital Y. The same thing which we did for Henry and Faraday, or rather should I call it impedance and capacitance. And after that the interesting part will start. So first, remember, it is a long transmission line rigorous method which will involve gamma, and the calculations will be uh, very much complicated. So it's better to use programming rather than doing it by yourself, right? So what we will do, first we will find the value of IR, and we will be following the same simple formula, the formula of receiving in power, right? Root 3 VIR VR IR cos phi. So we will make IR subject and we will find the value of IR, and from that we will find the value of IR complex, and IR complex, we will be using this formula: IR into cos phi r minus J into sine of A cos phi r. So same formula for my complex IR as well, or IR star as well. Now we have to find the propagation constant. We have to find the gamma. So gamma L is square root of y into z into L, and we have been given what is the value of zc. So zc was square root of z by y. Remember, we had a variable called zc, which was actually square root of z by y when we were discussing the rigorous method. Based on that, we will find the ABCD parameters. Uh, the value of ABCD parameters we derived in the rigorous method. So I'm not going to explain how did we got it here, but these were the values, and we just mentioned it over here. Now the same thing which we did for medium transmission line in the both cases T and pi, we will do the same thing. We will find the value of Vs and Is, sending in voltage and current, based on ABCD parameters and my phase voltage and IR star. Based on that, again I will find value of VSL and ISL, line voltage and line current, and I will be finding the value of sending in power factor. Same thing again, and same formulas again, nothing new here. Okay, new thing although will be here in the voltage regulation calculations, right? Last time we found VRNL, same ways we will finding VRNL this time as well, but to find the voltage regulation we need to take the absolute of VRNL. So we will take absolute of VRNL, and after doing that we will be able to find the value of voltage regulation. So here is the formula of voltage regulation in line 37. Voltage regulation is equals to VRNL minus VRPH, phase of receiving end voltage, phase value of receiving end voltage, divided by again phase value of receiving end voltage into 100, and it will give us the value of voltage regulations. Same ways we can find the efficiency. What will be the efficiency? It will be again, for efficiency we will be using same formula every single time, because that is the only and the most efficient way to find the efficiency. So PS is equals to square root root 3 VLIL cos phi, and by finding PS you already know the value of PR. Efficiency will be PR by PS into 100, which will give you efficiency. Here I forgot to multiply it with 100, so what did I do? I took another variable called the efficiency, but I made the e small, and then I multiplied it with 100, right? And always remember, MATLAB is a case sensitive, just like any other programming language, be it C, Java or Python. MATLAB is also case sensitive. And then we printed our results same ways as previous. So that was your fourth experiment. Let's try to run it and see if it works or not. Let's run it. So we have been asked to enter the value of PR. Let's enter the value of PR from outputs. PR was 125, VR was 215. 125, sorry, not here, here we have to enter 125. VR was 215 or 225? VR was actually 215. 215. Value of Z, always be careful while entering these values, because I often mess it up. So Z is equals to 0.1603 plus 1603 plus J into, what was the other value? 1603 plus J into 0.8277. 0.8277, and enter. Now they are asking for value of Y. So Y was equals to J into 5.105, J into 5.105 j into 5.105 into 10 raised to minus 6 into 10 raised to minus 6. Now we have been asked to enter the length. Length is 130 and power factor is unity. So 130, let's make sure one more time. 130, sorry, length is 370. Apologies guys, length is 370 and power factor is unity. And let's see, um what we are getting. The sending end current is 331 amperes, sending end voltage is 252302 amperes. So 331 amperes, 252302 amperes. Power factor is 0.999, 0.999 historical. Efficiency is 86% and voltage regulation is 61%. Did you notice one thing, that voltage regulation in short transmission line was very less, in medium it was a little bit more than that, and in big transmission lines, long transmission lines, it suddenly took a high, it suddenly reached too high, right? Can you tell me why and how did it happen? I will be giving you shout out to person who can explain it to me in comment section below. The first person who will explain will get a shout out. Now that out of the line, let's move to the fifth experiment. We have just two more remaining, so let's first clear the screen, workspace and command window quickly. Okay, so that's clear. Now let's see the fifth experiment. Now we have been asked to write a simple program to calculate the ABCD parameters for any transmission line. Okay, and we know what are the formulas to find the value of ABCD parameters for every transmission line. So how will we find it, right? So let's see, we already have the code here, right? So this will be a little different because we will be using few new tricks here, so I will be explaining it to you meanwhile, no need to fear. Let's see what will happen. So we will need to find the ABCD parameters for all short, medium and long transmission lines. So you know the formula are different for all three lines, right? The ABCD parameters will differ for short, long and medium transmission lines. So what will happen here, firstly, CLC and clear all, I'm mentioning it editor itself because I was tired of clearing everything out after each and every of my command, each and every run of my editor script. So I'm mentioning it in the script itself from now on, so we can save the bother. After that, we will ask the user to enter one choice, right? Remember when you call a customer care and it will ask you that press 1 for this, press 2 for this, press 3 for this is a little bit similar to that. We will ask them to make a choice, right? They can press 1 for short transmission line, they can press 2 for medium transmission line, and they can press 3 for longer transmission lines, and based on that we will move forward as well. Now let's see how. Then we are putting a variable named check. What it will do, uh, it will take the input of whatever choice that person enters, right? Disp is the command to display something in result. So disp will simply display whatever you will enter. You can use the fprintf as well here, no issue. Whatever you want to use, you can use. You can disp, you can use the disp, or you can use the fprintf. So I have used disp here, you can use the fprintf as well. So disp, it will ask, it will tell us that 1 is for short transmission line, 2 for medium transmission line, and 3 for long transmission line. Now whatever the input you will enter, the check will ask you to enter your choice, and whatever input you will enter, based on that we will do the calculations. After that, whatever input you ask, despite of whatever input you ask, input you enter, it will ask you to enter few other things, like it will ask you to enter the value of resistance, inductance, capacitance, length of your transmission line, and frequency. And based on that, it will calculate the value of total resistance, because remember this resistance, inductance, what capacitance, whatever you enter, will be line per phase per kilometer, right? So you need to multiply it with whatever the length of your line will be. So you will be multiplying R with L. Same with inductor, because you are entering the value of inductance here, so you need to convert it into the reactance, so you will be multiplying with 2 pi f with L. And after that you will be multiplying it with the length of your transmission line in order to find the total length of your reactance. uh, After that you will be finding value of Z. So you will be finding your impedance. After that you will be finding value of Y. The same formula here as well. Y is equals to J into 2 pi f C into L. So I'm not explaining it one more time. Now it will check if you have entered 1, right? What is the value of 1? 1 is for short transmission line. So it will check, okay, what were the values for short transmission line. For the short transmission line, the value of A was 1, value of B was Z, C was 0, and value of D was 1. So it will give you the result in matrix form. So the result short is the output variable, and it is showing us the result A, B, C, D. So this is basically a matrix formation. Remember, we in the initiation of this session we learned how to draw a matrix. So it will show us the matrix, and it will show us the value of matrix A, then B, then C, and D. See, there is a semicolon here, so after A and B there will be a new row, which are C and D. So matrix will be 2 by 2, right? And it will end there. So short transmission line was the most favorite of mine because it was simple and sweet. But when you go for medium transmission line, you have nominal pi and nominal t methodologies, and for both of them you have to because for both of them the value of nominal pi, and for the value of nominal pi you will have different generalized parameters, different ABCD parameters, and for value of nominal t there will be different parameters values. So we have to do it for both of them. And how do we do it? So again, if the value you have entered is 2, what you will do, it will display you, it will give you the choice again, because we have again nominal pi and nominal t transformation. So it will ask you for which one you want to do it. Enter 1 for medium transmission line, medium nominal pi transmission line, and enter 2 for medium nominal t transmission line. And this variable s will take the input from you. Okay, it will ask you to enter your choice, and whatever the choice you enter, based on that we have one more loop as well. So when you enter 1, it will do it for nominal pi transmission. For nominal pi, value of ABCD are given here. If you want to verify it, you can check the lectures. I have already provided the link of all the playlist right in description, so you can check it. Same ways, if s is not 1, that means s is 2, right? So if s is 2, then you are asking for nominal t, and for nominal t we have these values of ABCD parameters. uh, Again, same ways we have took the result medium for pi as the output variable for nominal pi, and result medium t is the output variable for nominal t. And again we have printed the values of A, B, C, D the same manner we did for short transmission line for both nominal p and nominal pi. Now comes the third one, the long transmission line. So For long transmission line, because you have to find the value of gamma L, so you have to do the calculation first, and then you will be able to move forward towards the ABCD parameters. So first, if we will check if the entered number is 3. If entered number is 3, then what we will do, we will put gamma L is equals to square root of y into z. So because we haven't entered the value of y and z, and gamma L is only available for the long transmission line, it is only present in the rigorous method, so we cannot find the gamma L for all of them, right? It will be wastage of one variable. So we will find the gamma L only if you have the long transmission line. And for long transmission line, what you can do, you can find the gamma L, and then you can find the ZC, which is nothing but the square root of z by y. And once you find it, you can find the value of ABCD parameters. You already know what are the values of ABCD parameters from the lectures we took, and based on that we can find the result matrix. Result underscore long transmission line is the output variable for long transmission lines, and same ways we plotted the matrix for all the transmission lines, we will plot the matrix for long transmission line as well, and the code will end, right? So let's try to run it and see if that works. We will verify it for we will verify it with the outputs present in our manual. So see here, it is asking us enter your choice, and it is asking us 1 for short transmission, 2 for medium, and 3 for long. So let's try to find it for short transmission line first, then we will find for medium. See, enter. I have entered 1. Now it is asking for the value of resistance. Now let's see what values we have entered here. Based on that we will see. R is 0.3, so R will be 0.3 here. What is the value of L here? L is 1.59 into 10 raised to minus 3. 1.59 into 10 raised to minus 3. Value of C, remember for short transmission line we neglect all the capacitance effect, which means the capacitor value will be 0, although let's verify it one more time. Okay, yes, capacitance is 0, line length is 15, and frequency is 50. So let's enter. Line length is 15 kilometers and frequency is 50 hertz. And here we are getting the value of our ABCD parameters in complex form and in a matrix form. Okay, so the A is 1.0, D and A will be same, 1.0 1.0. The B will be 4.5 plus 7 7.4927i, and C will be 0, completely 0. Let's verify it. So here you are, you can see the value of A, B, C and D, 1 1 0 and 4.5 plus 7.4927i. So it does matches, right? Now let's try to enter the same thing. Let's try to do the same thing, but this time for medium transmission line. So let's clear all and CLC, and then we will run the whole command one more time. Here you go. This time let's enter 2 for medium transmission line. Now this time they are asking us for the value of resistance. Okay, so let's say what are the value of resistance this time when we are going for medium transmission line. Let's see. Okay, so the value of resistance R is equals to 0.153. R is 0.153. Value of L is what is the value of L? 1.21 into 10 raised to minus 3. So we have 1.21 into 10 raised to minus 3. The value of C is given to us as 0.00958 into 10 raised to minus 6. 0.00958 or 985, what was it? 958 into 10 raised to minus 3. The length of the line is given as 100 kilometers and the frequency is 50. So length is 100 kilometers, frequency is 50 again. And now see, as this is a medium transmission line, it will have two analogies. It will have nominal pi and it will have nominal t. So it is asking us, because we programmed it that way. Now which one you want to go for, nominal pi or nominal t? So let's choose option A. Let's see what will happen when we enter the nominal pi. So here you go with option A, nominal pi, and it is giving us minus 4.7207, minus 4.7203 plus 2.3024 I, something like that. So are we getting it? Where is my where is the value of nominal? Okay, nominal pi, no, we are not getting it. 0.9943 we are getting. Why is that? I think I have entered any some of the values wrong. Okay, capacitance was 10 raised to minus 6. We actually entered 10 raised to minus 3 here. That is why we are not getting the same value as them. Okay, so you can rectify it and you can try to find it. You can check it if we are getting the same thing or not. If you are not, if you have any doubt, you can mention it in the comment below. Now let's try the same thing for the long transmission line, but for before that, again let's clear the clear the clutter. So clear all one more time and then we will go for CLC, or maybe we can just run the code one more time as well, because we already mentioned clear all and close all in the beginning, right? I forgot. So again it's asking us to enter the choice. We will this time enter 3. We want to go for the long transmission line. Here you go, 3. Now let's see what were the values of resistance and all the other things. So here we have 3 and the resistance is 0.153. Inductance is 1.12 into 10 raised to minus 3. 1.12 into 10 raised to minus 3. Then capacitance was 0.00958 into 10 raised to minus 6. So 0.00958 or 985, again I missed it. 958 into 10 raised to minus 6. Length of the line will be long because it is long line, 370 kilometers, and frequency is 50. So 370 kilometers, frequency is 50, and here you go with the results. This 1.0 e into 10 raised to e raised to 10 raised to 2 will be the value of gamma L, and here are your output variables. A is 0.0092 plus 0.0003 I. So here you can verify we are getting the same values, 0.0092 plus 0.0000 I. B will be 0.5369 plus 1.3759. So yes, 0.5369, 1.5359, and C is 0, D will be same as A, right? So that was your 5th practical. Now again let's clear the clutter. Let's move forward till the towards the 6th practical. So this time this in the 6th practical, what we have been asked that we need to find the per unit computations for power system networks, and what do we need to find out is given here. Single line diagram 3-phase power system has been shown in the figure. Now my figure doesn't matter over here. Let's select a common base of 100 MVA and 22 kV on generator side. So you have already been given what is the base values of voltage and what is the base value of your power, and draw impedance diagram with all impedances including load impedance marked in per unit. So you have to draw the figure in the space given here itself, in the manual I mean, not in the MATLAB. And then the rating of each device and per unit impedances with own rating has been given in this table. As you can see here, we have four generators, T1, T2, T3, T4, and 100 MVA is the base value, 22 kV is base value, and then the values of power and voltage of generator respectively has been given for all T1, T2, T3, T4. Except that there is one more thing which they did, that they also gave you the base reactance value as well, 0.11 per unit next to 22 kV voltage. And after that they have given the reactance values of all the T1, T2, T3, T4 generators. The other details which have been provided to you are the load of 45 MVA, power factor is 0.8, voltage is 10 kV, and that is connected to the second bus. The line 1 and line 2 both are having the reactances of 0.5 kilometers and 0.7 kilometers, 0.7 ohm per kilometer respectively, and 0.5 kilometer per 0.5 ohm per kilometer respectively. So you have to find the per unit quantities, per unit values, and here we have the code for that. So because we are all the values have been given, and we cannot ask the user who is running the code to enter all those values one by one, because the values will be too much, right? There will be too much values, and that will be too much hassle. So we will take the values, uh, we will take the values by ourselves this time. Not ask We will not ask the user who is running the code to enter the values. So uh, so that we can do it simply, right? So first, the per unit generator reactance 0.11, as you can see here. As you can see here, they took x is equals to 0.11 per unit. So we did to xg old, we have named it. So base values have been named with underscore old. Same with gen 1 voltage rating 22, and MVA gen 1 power rating, generator power rating 100. Then the base value of voltage is 22, so kVb has been used for it, and base value of power, we used MVAB for base values. Then this is the formula for per unit reactance. This one is for the first generator, we called it xg1 underscore new. And you pretty much are familiar with per unit values and per unit quantities, how to find the per unit quantity values. So we simply take the ratio, we take the ratio of your actual value divided by base value, and based on that you can find it. So to find the reactance of g1, we simply took g1 of old, and then we multiplied with its MVA divided by the old MVA, so ratio of MVAs into the ratio of KVs. Okay, the old KV divided by uh, the present KV, and then we took the square of it. So that was the formula for XG new. That was the formula for XG new, and we found value of XG. Same ways we will do for MVA. So you can see MVA T1 for MVA rating of your transformer, then HV voltage rating, then LV voltage rating, and then the power per unit reactance of your transformer. And here is the formula for your per unit reactance for transformer, same ways for generator, and you can find it. The variable has been called xt1 underscore new. Same ways for you can do it for your other transformer. The change in your kilowatt in the base, you can find it. So The formula will remain same, and for formula please refer the previous lectures which we discussed in the very first playlist. Then for the rest of the generators, we entered values of their inductances, reactances, um resistances one by one. See here we took L, XL for the length of the line. This is the calculation for line. Now we are starting. So L, XL, XL old and XL new, right? So XL old is the line reactance for total whole length of the line, and XL new is the uh, calculation for the impedance of line, right? So XL new will give you the per unit impedance of your line. Based on that, you can find MVA of your not MVA. You can find the change in kV in the base in transformer, and for that you already have the value of MVA of your transformer. You already have the HV voltage rating of your transformer. You already have LV voltage rating of your transformer and per unit reactance of transformer. Same way as we did for the first one, we will do for the second one, right? We had two generators, we have two transformers, so same way as we did for generator 1, transformer 1, we will do for generator 2, transformer 2. And whatever we will find the change in base in transformer, we will call it KVBT2. And based on that you will find xt2 new, which will be your per unit reactance of transformer. And again same formula will be repeated, this time for second transformer. Then you will be calculating MVA of transformer, which has already been given to you. You will be just putting it over here. And same thing for the kV rating. KV has been also given to us. We already calculated the per unit reactance of your transformer, so you will be putting it over there. And then you will calculate the change in kV in the base in transformer, and you will indicate it with the help of kvbt3. And based on the value of kvbt3, you can find the value of the per unit reactance of your transformer xt3 new, right? This is xt3 new I'm talking about, not talking about xt2 new. Okay, so that was the second transformer, this is the third transformer. Same ways you can calculate the value for other transformers as well. So the calculation has been given here for all the transformers, and when you get done by that, you can print all the values here, right? Pretty much simple calculations. So let's try to run it, and this time, because we are already entered the value manually in our code itself, so it will not ask for any values, it will directly give us the output. So let's run it and see what will we get. See, we are getting so many variables here in my workspace. There are so many variables, and it does make sense, right? Because we had so many variables in our code itself as well. So the outputs it is giving us is LVT3 old is 11, KVBT3 is 1.1, and LX2 is old is 70. Let's try to match it. So point 2, point 1, it is giving the per unit reactance directly. Okay, in output they have mentioned the per unit reactance directly. They haven't mentioned LVT3, KVBT3, and XL2. So the per unit reactance of transformer, first transformer is 0.2. Let's match it. Yes, it is 0.2. For second transformer it is 0.175, so 0.175. Third transformer uh, 0.046875. Okay, we are not getting the same value here because I think I must have made some error while writing the code itself. Okay, no issues. Let's see for the fourth transformer, 0.0039. 0.0039. Okay, so I'm not matching the third transformer because I think I have made some error while writing the code. I entered some value wrong in the process. And then for the generator, motor, and two lines, 0.11 and 0.003906. So we have generator, we are getting correct, 0.11, 0.003906, and both of the lines we have 10336 for the first line, 0.10336, and for second line 0.036157. Second line 0.036157. So all the values of reactances are matching. So whenever you write the code, try to find out what mistakes were made in the calculation of third transformer, so that we can rectify it next time. And we will complete it till the sixth experiment only, because the 7, 8, 9, 10 experiment, the four experiment, are yet to be performed. And after performing that only, the theory part, I mean, after completing the theory part of it, we will come to the practical coding of practical experimentation of all those experiments as well. So this was something new I tried. So please let me know how did you find it, and was that any helpful to you or not. Did it help you to learn about MATLAB and its basics as well, about the power system as well. So please feel free to drop your feedbacks in the comment section below. If you have any other thing to tell me, you can mention it in the comment section below as well. Also, if you have any doubts or any queries related to the codes we wrote, or in the theory, you can mention in the comment section below. Any issues with code or practicality as well, you can feel free to contact me. I will try to answer your queries as soon as I can, and as quick as possible. So until next time, thank you very much for listening. It has been a long session, so thank you very much for listening. I will be seeing you the next time. Till then, goodbye. Thank you very much.